Reality does not simply exist, it appears when observed. This is the unsettling claim at the heart of the observer paradox, that the physical world may depend on conscious observation to become real. In quantum mechanics, this is not poetry, but data. Experiments like the double-slit test show that light behaves as both a wave and a particle, but only decides which when we look. Observation seems to collapse a spectrum of possibilities into a single fact. Before that act, the universe remains a blur of probabilities, as if waiting for awareness to notice it. This is not about perception altering what we see, but whether anything definite exists before it is seen. A photon moving through space has no fixed path until it interacts with a measuring device, or with you. The apparatus records one history among countless potential ones, and that recording becomes the event. Physics once sought an objective world that existed independently of us. Quantum theory quietly dismantled that assumption. The question now isn't what the world is made of, but what it means for something to be real at all. If observation creates reality, then the boundary between mind and matter dissolves. Consciousness stops being a spectator and becomes a participant in the universe's unfolding. Each act of measurement might be a moment of cosmic selection, where infinite possibilities shrink to one lived world. The paradox is this: we think we're discovering reality, but perhaps we're continuously constructing it. The unsettling implication remains. Without observation, the universe might persist as pure potential, existing not as things, but as the possibility of things. And when you open your eyes, that infinite uncertainty crystallizes into a single world, the one you now call real. At the core of the observer paradox lies one of the strangest phenomena in all of physics: wave function collapse. In quantum mechanics, every particle, electron, photon, atom, is described not as a solid object, but as a wave of probability. This wave encodes all possible positions, velocities, and states the particle could occupy. Until a measurement occurs, those possibilities coexist in a kind of suspended reality known as superposition. The act of observing does not simply reveal which possibility was real all along, it decides it. Consider the double-slit experiment. When photons are fired through two slits toward a screen, they create an interference pattern, evidence of wave behavior. But if detectors are placed to see which slit each photon passes through, the pattern vanishes. The same photons now behave as particles, choosing one path or the other. Nothing physical about the setup changes except the presence of observation. The universe seems to ask, "Are you watching?" and then changes its behavior accordingly. This is not metaphorical. Quantum theory's mathematics predicts that until observation, all outcomes exist simultaneously, weighted by their probabilities. Observation forces the wave function to collapse into one outcome, which becomes actualized in space-time. Yet physicists cannot agree what performs this collapse. Is it the measuring device, the act of recording data, or the conscious awareness of the observer reading it? The equations remain silent, offering only the mechanism, not the cause. Einstein resisted this conclusion, famously remarking, "I like to think the moon is there even if I'm not looking at it." But quantum evidence suggests that, at the smallest scales, existence is not a given. It is conditional. The world's solidity may depend on moments of observation that carve reality from possibility. What this reveals is almost unbearable. Beneath the surface of the visible world lies not matter, but mathematics. Patterns that become physical only when attention collapses them. Reality is not the background stage of existence. It may be the ongoing performance of observation itself. The observer paradox deepens inside what physicists call the measurement problem, the unresolved mystery of what precisely constitutes an observation. In quantum mechanics, measurement seems to have a unique power to turn potential into actuality. But the equations do not define who or what performs that act. Is it the human mind, the measuring device, or some deeper interaction between system and environment? The boundary between quantum uncertainty and classical certainty remains disturbingly unclear. In theory, a measurement is any interaction that entangles a quantum system with something larger, forcing one of its possible states to become definite. But this definition only postpones the problem. What counts as larger? If a photon hits a detector, the detector's atoms become entangled with the photon's state. Yet those atoms are still quantum systems themselves. The chain of entanglements grows. Detector to circuit, circuit to computer, computer to human. At which link does the collapse occur? Physics offers no natural stopping point. It is as if the universe refuses to finalize its own facts until awareness appears. This unresolved boundary is sometimes called the Heisenberg cut, the invisible divide where quantum possibilities end and classical reality begins. But no one knows where to draw it. Move it closer to the measuring device, and consciousness seems unnecessary. Move it closer to the observer, and the mind itself becomes the mechanism of creation. The equations stay intact either way, but our picture of reality changes completely. Some interpretations, like the Copenhagen model, simply accept collapse as fundamental, an event without explanation. Others, like the many worlds interpretation, deny collapse altogether, claiming every possible outcome occurs in a branching universe. Yet both positions face the same haunting truth. Whatever reality is, it becomes knowable only through the act of measurement. The paradox thus remains intact. The more precisely we try to define observation, the more it retreats from definition. What we call the real world might not be something we find, but something that forms at the instant we look for it. When the equations of quantum mechanics refuse to tell us what reality is doing between observations, interpretations arise to fill the silence. Each one attempts to make sense of the same data, the same experiments that show particles acting like waves until measured. Yet each paints a radically different portrait of existence. None can be proven, because all predict identical results. What changes is not the physics, but the meaning of observation itself. The Copenhagen interpretation, born from Niels Bohr's school of thought, accepts collapse as an ultimate fact of nature. The observer doesn't create reality but finalizes it, forcing a quantum system to commit to one possibility. Bohr insisted that physics should concern itself only with what can be measured, not with what really happens before measurement. Reality in this view is inherently participatory, unfinished until observed. It is not that consciousness causes collapse, but that observation defines what can exist meaningfully. The many worlds interpretation proposed by Hugh Everett rejects collapse entirely. Instead, the wave function never chooses, it branches. Every possible outcome of every quantum event occurs, but in separate, non-communicating universes. When you measure a photon, one version of you observes it go left, another sees it go right. Both outcomes are real, but isolated within parallel realities. What appears to be randomness is simply your consciousness finding itself in one branch among many. Observation does not destroy possibilities, it multiplies them. A third view, quantum decoherence, seeks to remove the mystical edge by treating collapse as an illusion. It argues that quantum systems interacting with their environment lose coherence. Their superpositions effectively blur out into classical outcomes. No consciousness required, just the mathematics of entanglement. But decoherence explains how superpositions disappear, not why one particular result appears in your awareness. The mystery only shifts location, from physics to perception. All three interpretations agree on the evidence, but disagree on the world behind it. And that disagreement may be the point. Perhaps reality's structure is not something observation reveals, but something it creates in layers of meaning. When the universe offers multiple interpretations that all fit, the paradox isn't in the equations, it's in the act of understanding itself. If observation transforms possibility into reality, we must ask, what is the nature of the observer? Does consciousness merely register outcomes, or does it help produce them? The answer defines not just physics, but the status of the human mind within the cosmos. For most of science, consciousness was treated as an after-effect of matter, a byproduct of neurons firing. But in the observer paradox, that hierarchy begins to invert. Mind may not arise from matter. Matter may arise through mind. Physicist John von Neumann noticed that quantum theory allows the measurement chain to extend indefinitely, from particle to device, from device to brain, but never specifies where it must end. He proposed that only consciousness, being non-physical, could finalize collapse. The wave function, he argued, doesn't resolve into a single reality until a conscious observer perceives the result. In this view, awareness is not an epiphenomenon of physics. It is the final step of it. Eugene Wigner extended this idea with his thought experiment, Wigner's friend. Imagine an observer's friend measures a particle inside a sealed lab. To the friend, the outcome is definite, but to Wigner outside, both friend and particle remain in superposition until he observes them. The paradox is recursive. Consciousness seems required to collapse the world, yet each conscious being is themselves part of another's uncollapsed reality. Observation creates facts, but those facts depend on who is looking. Many scientists resist invoking consciousness, preferring purely physical mechanisms. Yet, even they admit that quantum mechanics leaves no place for an entirely observer-free universe. Every physical event is defined in relation to measurement, and every measurement implies some kind of awareness. What this reveals is profound. Consciousness and reality might be two sides of the same process, the universe knowing itself through observation. The observer is not outside the experiment, but within it. To observe may be to exist. To exist may be to observe. The paradox loops inward, suggesting that reality's foundation could be the very act of being aware at all. If the observer paradox suggests that measurement defines reality, entanglement reveals how deeply that definition can reach. When two particles become entangled, their properties intertwine so completely that measuring one instantly determines the state of the other, no matter the distance between them. Einstein called this spooky action at a distance, a phrase born of disbelief. For him, nothing should travel faster than light. Yet, experiments prove that entangled particles behave as if they share a single unified state across space and time. In the quantum description, two entangled particles are not separate objects. They are one system described by a single wave function. When an observer measures one particle, the entire system's probabilities collapse into a definite configuration. It's not that information travels faster than light, it's that the system never needed to send it. The universe already knew the outcome because at the fundamental level, it was always one thing. This interdependence forces a radical reconsideration of observation itself. When you observe an entangled particle, your measurement doesn't simply reveal its state, it reshapes the joint reality of both. Observation ceases to be a local act, it becomes global. Reality behaves as if it is indivisible, self-aware, and immediately responsive to the act of being known. Some physicists interpret this as a hint that reality's fabric might be informational rather than material. Quantum information theory treats the universe as a vast network of correlations, where observation doesn't transmit facts, but selects them from an already connected totality. What collapses is not distance, but uncertainty, the unknown resolving itself through knowledge. The paradox sharpens. Every observation affects not just the thing observed, but the entire web of relations that define it. To know one part of the universe is to alter its whole. In that sense, consciousness doesn't merely witness entanglement, it participates in it. The universe does not stand apart, waiting to be seen. It exists through the act of seeing itself. Entanglement unsettles not only space, but time itself. In the quantum world, cause and effect lose their familiar order. Experiments such as Wheeler's delayed choice test suggest that decisions made in the present can determine what happened in the past. A photon's path through a double-slit apparatus appears to depend on whether we later choose to observe it. The act of measurement seems to reach backward, rewriting history so that it always aligns with what is ultimately seen. In this experiment, a photon passes through a pair of slits before a final detection setup is chosen, sometimes after the photon should have already decided its path. Yet the results show that the photon behaves as if it knew the future configuration all along. Observation doesn't reveal a past event, it defines it. Time, once considered an immutable flow from cause to consequence, becomes another dimension entangled with awareness. Quantum mechanics itself is time-symmetric. The equations work identically forward or backward. What changes is our experience of observation. We remember the past, not the future. But if collapse can be delayed until the moment of measurement, the universe may not store a complete history waiting to be found. It may reconstruct that history on demand, consistent with each observer's knowledge. What we call the past could be a continuously updated record, not a fixed archive. This idea unsettles every classical intuition. If observation can determine what has already occurred, causality loses its absolute hierarchy. The arrow of time may bend around the act of knowing, making the observer not just a participant in the present, but a sculptor of the past. The paradox deepens. Reality does not unfold and then become observed. Observation may be the process through which unfolding itself acquires meaning. Time, like space, might exist only where consciousness touches it, each moment collapsing into reality the instant it is witnessed. If observation shapes not just space and time, but the very texture of existence, then perhaps the universe is not a collection of solid objects, but an unfolding of information. Modern physics increasingly treats the world as a network of data encoded on quantum states. The laws of nature appear less like instructions for things and more like algorithms for relationships, how bits of information influence each other through observation. This vision culminates in the holographic principle, the idea that all the information in a volume of space can be described on its boundary, as if reality itself were a projection. In a hologram, every fragment contains the pattern of the whole. Similarly, every quantum interaction seems to reflect the universe's total information state. When an observer measures a system, they don't extract information, they complete it. Observation is not a passive reading of the world's code, it's the moment that code runs. The measured outcome is the rendered frame of a deeper computational process, one that requires participation to exist. Physicist John Archibald Wheeler expressed this in 3 words: it from bit. Reality, he suggested, is built not from matter, but from acts of observation, each measurement adding a bit of information to the universe's self-description. What we call existence could be the cumulative record of what has been observed, and what remains unobserved remains only as mathematical potential, waiting for interaction to bring it forth. This transforms the observer paradox from a mystery of physics into a question of meaning. If the universe is informational, then consciousness might be its decoding function, the way reality experiences itself. Observation would not distort the universe, it would instantiate it. Each act of awareness writes another line into the cosmic hologram, and so the paradox expands. The more we understand reality as information, the less distinction remains between observer and observed. The screen on which the universe projects itself may be the very act of looking. John Wheeler once proposed a staggering idea. The universe is not merely observed by consciousness. It requires consciousness to exist in any definite form. He called this the participatory anthropic principle. The concept overturns the passive image of a pre-existing cosmos, replacing it with one in which observers are woven into the fabric of creation itself. Reality, in this view, is not a thing that happened long ago and continues without us. It is a dialogue between the universe and the beings capable of noticing it. Imagine a cosmic feedback loop. The universe gives rise to life. Life gives rise to consciousness, and consciousness in turn brings the universe into specific existence. Observation is no longer a local event. It becomes the closing link in a vast causal circle. Without observers, the universe remains in a superposition of all possible histories. With them, it chooses a path that allows those very observers to exist. Wheeler called this the self-excited circuit, the universe observing itself into being. This is not mysticism, but logical extension. Quantum experiments show that outcomes depend on measurement. Cosmology shows that measurement depends on intelligent life. Therefore, the act of observation might be the final boundary condition of reality. The universe may be structured in such a way that it becomes fully defined only once observers emerge within it. From that perspective, we are not accidental byproducts of cosmic evolution. We are its means of completion. The paradox thus loops on a cosmic scale. The universe creates observers who, through observation, create the universe. It is an ontological mirror with no starting point. The Big Bang, under this lens, may not be an event in the distant past, but a boundary in meaning, the moment when potential began to be known. The implication is almost unbearable in its symmetry. Perhaps existence is not a solitary monologue of matter, but a participatory act of recognition. The universe becomes real only where it becomes aware of itself. If reality exists through observation, then consciousness is not an incidental flicker in an indifferent cosmos. It is the lens through which existence takes shape. The observer paradox turns our ordinary sense of being inside the universe into something far more profound. The universe might be inside the act of being us. Every perception, every thought, may be a quantum boundary where possibility hardens into experience. Human awareness, with all its fragility, becomes a cosmic instrument. Each time you notice light reflecting off a surface or recognize the sound of your own heartbeat, you are collapsing countless quantum uncertainties into one consistent world. The brain itself might function as a living measurement device, synchronizing the probabilistic haze of microscopic events into the coherent continuity we call perception. Observation is not passive reception. It is creative participation. To know is to form. Free will, too, begins to transform under this light. If observation selects among possibilities, then choice is not an illusion, but the physical mechanism through which potential becomes reality. Decision and measurement may be two sides of the same coin, one cognitive, one physical. The future does not pre-exist waiting to be discovered. It crystallizes in the moment attention meets possibility. The observer's will may therefore be woven into the universe's causal fabric itself. This view does not exalt humanity, but integrates it. The same principle that applies to photons and atoms applies to thoughts and choices. Reality unfolds relationally through participation. The observer and the observed are entangled, sharing one informational continuum. The boundaries between consciousness and cosmos, self and environment, dissolve into mutual definition. The paradox tightens into clarity. To exist is to observe. To observe is to co-create. The human mind may be the way the universe achieves local awareness of itself, a temporary window through which the infinite confirms that it exists. Across centuries of inquiry, physics has tried to separate the knower from the known, the map from the territory. The observer paradox dissolves that division. What it reveals is not a universe split between subject and object, but a single, self-consistent process that requires both to exist. Observation and reality are not opposing sides of a mystery. They are two expressions of the same event. The paradox endures only when we imagine they are different. At every scale, from subatomic to cosmic, the same pattern repeats. Possibility becomes actuality through interaction. Measurement, consciousness, and causality all describe one underlying act, the exchange of information that turns potential into structure. Whether it's a photon meeting a detector, a neuron registering perception, or a galaxy bending light, the mechanism is identical. The universe knowing itself through relation. Observation is not something that happens inside reality. It is how reality happens. The boundary between observer and observed, once thought fundamental, now appears artificial. When consciousness collapses a wave function, it is not reaching into matter from outside. It is the inside of matter recognizing its own state. Reality does not pre-exist awareness, nor does awareness float above reality. They co-arise like two sides of a single coin that can never be separated or seen at once. This is the hidden coherence. The universe and the observer are not linked by cause, but by identity. What we call collapse might be the moment unity becomes differentiated, when the infinite perceives itself as finite. Observation is the fracture through which the whole experiences parts. Without that fracture, nothing could appear. With it, existence begins to see. The paradox resolves itself by turning inward. Reality is not dependent on the observer as an external cause. The observer is reality observing itself. The mystery was never about how the universe responds to us, but how we are the universe, learning to notice. Reality does not wait to be seen, yet it is never complete without the act of seeing. The observer paradox was never a riddle about photons or equations. It was a mirror held up to existence itself, asking whether anything can be without awareness to witness it. The answer is both yes and no, because the question divides what cannot be divided. Reality and observation are two halves of one continuous act, the universe noticing itself into form. When you open your eyes, the world appears, colors, shapes, motion, but those patterns existed only as quantum potential until awareness aligned them into coherence. And when you close your eyes, the universe doesn't vanish. It simply retreats into probability, awaiting the next moment of recognition. Existence is not a static collection of objects, but a rhythm, appearance and withdrawal, observation and possibility, an unending pulse of being realized through attention. To look, then, is not to distort reality, but to give it focus. Consciousness is the lens through which the universe comes into definition. Every observer, every act of perception, is a local aperture in the cosmic field of awareness. Through you, the infinite confirms that it exists. Through you, the universe becomes particular. The paradox resolves when we stop imagining that reality and observation are separate entities in dialogue. They are one process, endlessly folding into itself. Existence, observing existence. What you see and the seeing of it are the same event, the moment the universe becomes aware that it is. So does reality exist only when you look? Yes, because looking is what existence means. And no, because what looks is reality itself. Right, I exist in the act of observing.